Hello everyone, my name is Upadhyayula and I handle the solutions enablement for Supermicro. First and foremost, thank you all for joining us in this hyperconvergence track. It's really exciting and we got a lot of content to cover. This session is divided into two segments. In the first segment, we are joined by our longtime friend and partner, Tobias, General Manager, Intel Optane SSD Group, along with Product Manager for Supermicro's BigTwin product, Michael Ocampo, and Rack Solutions Senior Architect, Sunny Chandrakumar. They will be talking about all the innovations we are bringing into this new hyperconvergence platform, and more importantly, talk about the use cases, the workloads, as well as the benchmarks that really benefits you. In the second segment, I'm joined by these presenters for a panel discussion to address your questions and also share their vision and roadmap for the hyperconverged infrastructure. With that, Michael.
Thank you, Sim. Hi, everyone. Thank you for joining us. Again, my name is Michael Ocampo. I'm the product manager for Twin Architecture Systems. And today I'm happy to feature our BigTwin product line, which is the go-to hyperconverged infrastructure platform. So as Sim mentioned, we're going to cover the platform as well as some performance metrics, as well as some information about Intel components and how they accelerate and improve the performance for hyperconverged infrastructure solutions. So we want to start off by reviewing some of our platforms within the BigTwin architecture. It's actually a very flexible solution from a storage perspective as well as for compute. So as you can see on screen, what we feature is a multi-node system with up to 4 nodes with dual processors or 2 nodes in each 2U enclosure. So we've been working very closely with our HCI partners as well as ISVs who are leveraging software such as VMware, Red Hat, as well as open source solutions to basically power virtualization as well as container technologies. And they're able to support multiple generations of compute and really push the envelope for performance with liquid cooling or air cooling. So a lot of our customers are using air cooling to basically have a very power efficient data center. So here's a review of what the system architecture looks like. So what you're looking at is basically an illustration of 2 different systems, and I'm going to play an animation to kind of walk through the different configurations that a customer can basically configure to order. So on the left side, we have 4 compute blocks. On the right side, we have 2 compute blocks. Both of these subsystems would fit into a 2U enclosure. And as you can see here, we have 2.5-inch drives, and those are typically SSDs or NVMe drives. And a lot of our customers are using a hybrid approach to basically cache information and using a tiered storage to basically have a very cost-optimized storage solution. So of course, you're able to use other form factors for the storage drives themselves. So here you're seeing what a 3.5-inch drive configuration would look like. And the beautiful thing about our system architecture is really the ability to change parts and swap them out whenever there's a service maintenance scheduled. So in this case, we're showing how the fans can easily be replaced. And even the power supplies are hot pluggable, so you can change those. And these are redundant power supplies. As a standard, we support 2200 watt power supplies. And for our BZ model, we feature a 2600 watt power supply with 16 counter-rotating fans. And these are an N+1 design to basically help improve the robustness and reduce the amount of downtime, as well as accelerate the ability to swap out nodes and service fans. Here you can see our SIOM module for flexible networking support. And you can see we support anywhere from 1 gig to 100 gig. Many of our customers are choosing at 25 gig, so many data centers have already migrated from 10 gig to 25 gig. That's pretty much the sweet spot. And we even have an option to basically support different form factors for 10 gigabit Ethernet. So we have a dual port 10G base T plus dual port SFP plus all in one card in that onboard option, while still having the ability to add additional add-on cards for redundancy or for more bandwidth for the data paths and storage connectivity. Speaking of storage, you can see the mid plane is also modular. So if customers are looking for NVMe connectivity and SATA only, we have that option to basically support that without adding any SAS controllers. But for customers that do want to have SAS storage, we also have an onboard option powered by Broadcom SAS 3008. And you'll see in my next slides, you'll see there's another option for hardware RAID 1 or SAS support, as well as other RAID options. And here you can see the nodes themselves are very easy to slide into the enclosure. So you can see how easy it is to upgrade and maintain these systems. So here's an overview of one of the building blocks or the nodes that represent the compute within the subsystems I just showed. So you can see there's a lot of good flexibility, and you can see we have a connector that basically interfaces with our backplane. So this backplane is the power delivery as well as the support for PM bus and sideband management controls. And no information is shared. So unlike a blade, each one of these systems is isolated from a network connectivity as well as base management control perspective. And what we're featuring here, which is very popular for hyperconverged infrastructure solutions, is a hardware RAID 1 for M.2. And here's what it looks like for our SIOM options. And one of our claim to fame for this particular solution is the ability to support 24 DIMMs, as well as Intel Optane DC persistent memory, or PMEM for short. Another popular option is this particular system that ends with HNC1R. So this is another 2U4 node option, but it actually has SAS hardware RAID 1, 5, 6, 10, 15 support. And that's enabled with a SAS controller that is added into slot number 1. We also see a lot of customers asking for connectivity with other legacy storage devices through fiber channel. So that's also supported through another add-on card with a low profile slot on the second slot here, which is connected to our CPU number 2. So there's a very high density solution with a lot of flexibility. So as a whole, BigTwin offers a lot of great advantages to enable it to become the ultimate hyperconverged building block. In previous sessions, we've talked about resource saving architectures, and we have a lot of built-in redundancies to ensure that all these nodes have maximum uptime. It's a very scalable building block in its form factor as far as how it's deployed and maintained, and it's a very high performance. So the motivation behind our architecture has been designed for high performance computing, and we've taken a lot of those innovations and applied it to hyperconverged infrastructure. So we're able to cool down these systems while supporting a lot of different storage options. We have very low latency storage. We have a pure NVMe option, and all the drives on the front are hot swappable. So it makes a very good solution to basically support these popular hyperconverged options like Acropolis, like vSAN, or Red Hat hyperconverged infrastructure for virtualization, even Windows Hyper-V. And we have a lot of great embedded technology to support CPU offload, network accelerators, and from a remote management perspective, we have a lot of standardized APIs that we support through our BMC. So this is very critical for provisioning, as well as doing some resource monitoring for all the critical components. So here's a benchmark that we did with VMMark, which showcases the ability of the BigTwin being an ideal hyperconverged infrastructure building block. As you can see from the stats, we are using our pure NVMe BigTwin with 2U4 node, a Platinum processor, times 8 actually, because there are 4 nodes. And in each node, there's 768 gigabytes of memory, Intel Optane drives for the caching tier, the P4510 from Intel for the data tier, as well as a redundant boot drive from Intel with a 240 gigabyte capacity, and another network controller from Intel based on Fortville, XXV710 for dual port 25 gig bandwidth. So what you're seeing here on the right is the actual performance of the VMMark score. So this is in one category for 4 hosts and 8 sockets. So this was the best result, and it's still today it's number 1 on VMware's website. You can take a look at the results on the bottom. That is a hyperlink that will bring you to the actual raw data for the result. And what you'll see is this tile score of 10.63 at 12 tiles. And basically what it's measuring are 4 different components. So vMotion, SVMotion, XVMotion, and deploy. So each one of those are basically measuring VM performance. So one for migrating virtual machines across the host, migrating VMs, storage and configuration files, and moving VM files across the host, and the actual deployment time from a standard template. So this version of VMMark is 3.1.1, so other OEM providers as well as our company has submitted various results, and this is a shining example of what our multi-node system can do for vSAN performance. So this is something that we're always staying abreast of. VMware has done a great job to continue to innovate, and now they're supporting Kubernetes using a container storage interface. So if you go check out VMware's website, you can see that we do have vSAN ready nodes based on the 3 BigTwin systems I've shown you today, which is based upon the HNC1R with SAS 3108, the other model that supports IT mode with SAS 3008, or the all-flash NVMe model, which actually supports 32 terabytes for the raw storage capacity. So before I hand it off to Intel, I just want to share one very powerful use case that basically is representative of how powerful the system and the satisfaction that our customers have with this particular platform. They're using our BigTwin with hardware RAID support for the front I/O, and this is a hyperscale customer, and they power e-commerce globally around the world. And they've been using the Twin architecture system for multiple generations, and as Intel releases new CPUs and new innovations at the microcode level as well as in the firmware optimization, we've been able to deliver more performance for our customer with the same system architecture. And they've even onboarded new systems with Cascade Lake Refresh, which is the second generation of Intel Xeon scalable processors. So again, this is one of the hallmarks of Supermicro's product portfolio, and we're very happy with this performance, and we want to thank Intel for supporting us and really helping us to enable new technologies. So with that said, I'll pass it over to Chris over at Intel.
All right, thanks, Michael. I'm Chris Tobias, and I manage the Optane Solutions division at Intel. And what I'm going to talk about is how Intel Optane SSDs help the HCI performance. And this is, extremely relevant for, Supermicro's BigTwin systems. So to keep it simple, Optane works in conjunction with other storage technologies like NAND. And you use a little bit of Optane SSDs with a lot of NAND SSDs, or you could even potentially use hard drives to create the best performance. And in HCI, it's really, really relevant. So we came up with this easy acronym to remember called ACT, A-C-T, to describe how Optane works in conjunction with the other storage media out there in order to deliver high performance. So starting on the left would be accelerating. And this is where you take metadata, logging, temp files, journals, write-ahead logs, etc., and you write them into the Optane layer for rapid access, since those are accessed regularly, and for rapid writing for change updates, and that improves the overall performance of the system. And then the capacity tier is usually all NAND flash, and it's converting now to all NVMe. So accelerating is storing data about data. The next thing we see is caching. And this temporarily holds a copy of data, usually as a write cache or as a read cache, or sometimes both. And the final one is called tiering, where there's actually the Optane layer is additive to the overall storage layer, and there's intelligent placement of data to maximize overall system performance. All three of these architectures will deliver better performance for you in your hyperconverged infrastructure system. How does it do that? Let me go into a little bit more in 4 ways of how Intel Optane SSDs improve ACT usages. First is it delivers higher IOPS. So in a 70-30 mixed read-write workload, it delivers 3 times the IOPS to break bottlenecks versus NAND SSDs. And it also delivers greater endurance, so up to 5x more terabytes written per dollar. So by using it as a cache, you get more performance and can use less amount for a cache. And then the really nice thing is it delivers lower latency. So versus your average NAND SSD, it's up to 5 times faster response time, which is super important if you're doing AI or big data analytics type of workloads. And it's very helpful in an HCI environment where you can minimize some of the performance costs of all the virtualization and get the flexibility of virtualization and performance. And then finally, you get better QoS. So with NAND, you have to do things like erase in big blocks, writing in pages, and move data around, which causes QoS, garbage collection, write amplification. And what happens in Optane is you write directly to the bit level. So none of those operations have to happen. And overall, this delivers a significantly better performance and consistent performance. So if you kind of look at this chart where performance can get spiky and unexpected delays happen on NAND, Optane is virtually flat and instantaneous response no matter what the workload conditions look like. So what does this mean, big picture? It means popular HCI workloads will perform better in Optane. And I'm going to hit 3 of these specifically. The ones along the top and give a little bit more data around those are Ceph, VMware, vSAN, and Nutanix, and how Optane can improve performance in those workloads. So let's take a first look at Ceph block storage. So one of the things you can do with Ceph is at a similar cost, you can have higher capacity, 2x the capacity per node. And the reason is Optane breaks the bottleneck by acting as that accelerating layer and enables metadata, write-ahead logs, et cetera, to be placed in the Optane. And it breaks that bottleneck and allows you to have 2x the storage per node at similar cost. So you can have fewer systems for deployment and much more storage dense with Optane. And then the IOPS are 10% better overall, and your P with 4 nines latency is 67% better. So overall, improved performance, higher storage density in a lower footprint. So good benefits all around for using open source Ceph or even using Red Hat Ceph. It supports both. And then let's look at the biggest, most popular HCI out there right now is vSAN for enterprise, and Optane works outstanding in vSAN. And what it does is you insert an Optane SSD for the cache layer, and this enables you to go from a 6-node cluster to a 4-node cluster, and gives you a 33% storage consolidation. It increases your overall TCO, and it gives you slightly better performance overall, and it's 60% VMMark VMs per node, so you can actually consolidate nodes. But if you look at the 6-node going to the 4-node, you get roughly equivalent performance, and this leads to about a 25% lower estimated 3-year server cost. So this is the same CPU, and we just swapped in a Intel Optane SSD for this performance difference. So it adds ready performance to your VMware vSAN node by adding in an Optane SSD. So this is Optane uses caching with VMware vSAN. And the final one I'm going to talk about is what we're having development with Nutanix. And Nutanix uses a tiering methodology, and we're working with them to improve the Acropolis operating system, and in our initial measurements, we're showing up to 2x the higher sustained write IOPS, and working with them, we've also improved the data path with Intel's SPDK and getting a 1.5x higher read IOPS, and the Intel Optane SSD is giving a roughly 2x lower latency. So we're very excited what we have in development with Nutanix, so we expect this to be available later this year. So stay tuned for announcements coming from Nutanix. So that's my quick coverage on what's happening with Intel Optane SSDs and hyperconverged infrastructure systems, and look forward to great success with Supermicro and their BigTwin system. And now I'm going to hand it over to Sunny to finish out the presentation.
Thank you, Chris. I'm Sunny Chandrakumar. I'm a senior solution architect at Supermicro. Today, we're going to talk about how we can use different servers option that we have, like the BigTwin server that Michael talked about, and using Octane drives that Chris talked about in our Supermicro solutions. So if you look at it, we have figured it out just so you don't have to. We will optimize your hardware and your software and do the build on a rack level or build the entire cluster solution, configure it as per your requirement thoroughly, and test it. So this way, when you receive the hardware and the software combined as a total solution, all you have to do is plug it to the power and you're good to go. And all this on a very affordable premium service. Moving on to the next slide, these are the different solutions that Supermicro has been offering, right? It goes from rack scale design from Intel to Red Hat, which is going for OpenStack, or IBM for GPFS solution, or Ceph storage for object storage, or if you want to go for HCI, you have Red Hat HCI solution, you have VMware vSAN, you have Nutanix, you have Microsoft HCI solution, etc. Now, moving on to the next slide. We have the offerings of these solutions in a way where we can actually fine-tune the solution as per your requirement. So let's say you have a requirement where you're running a database and that needs high performance, high throughput. So we will fine-tune our total solution in such a way that you have high CPU cores and high memory in your server that we are presenting it to you based on that, let's say if you're using BigTwin, and we will provide this total solution by including the software and testing it thoroughly on a functional level to make sure that the hardware works with other servers within the cluster and each of these components without any issues. Now, if you have a requirement where it is more inclined towards having a excess amount of storage, then we will provide you servers which will have options of high density of disk. So you can use NVMe drives, you can use SSDs, you can use spindle disk, and you'll have more storage in a single 2U space or a 1U space or in each node. So this basically tells you that we optimize your entire cluster based on your requirement, where you don't have to go with standard reference architecture that's designed by Supermicro. You have the flexibility of tuning it to your workload that you're running and to your business requirement. All right, so moving on to the next slide. This talks about the different services that we have in offering, right? Not only we provide hundreds of servers in terms of options that you have to choose from, but also different service packages that helps you to determine if you want to install a particular software, a particular application like database or machine learning or AI related applications, or if you want to do cluster level testing, or you want to do Hadoop testing or any of those kind of things, or HPC cluster management testing, or you want to do any kind of OS installation like Red Hat, Windows, any of those things, or VMware, or you just want a bare metal solution, right? So we have all of these in offering. Now, these offerings can be provided on a rack level or can be an a la carte where you don't have to include the rack, but the total cluster level solution, which includes with or without rack, can be tested completely. Now, the different kind of tests that we run when we optimize the solution to make sure that we meet a performance benchmark is basically we run CPU stress tests or temperature tests, memory performance tests. We would run parallel file system performance if you want to do a particular storage solution. You want to do object storage, we would do that as well. So what do we offer, right? We have the total BIOS setting firmware upgrade that we would do. We'll do a standard system level burn-in test. We'll do a fully automated cluster level test and configuration test to make sure that the versioning is same across the different servers in a cluster solution. We do an OS installation and configuration based on your requirement. We would do an IP setting or network configuration based on what in a network environment that you're running, a particular IP setting that needs to be set. We would do any application installation, let's say databases or running any big data Hadoop solution or any of those kind of things, configure them as per your requirement and benchmark these solutions and provide you a document which will talk about all these tests that we have run, which have failed and which have passed, and what changes we have done to make sure that you receive the total solution without any issues. So we go the all 11 yards, and this is basically tells you that we're running our own proprietary software that is built in-house to make sure that the cluster solution that is provided is tested from end to end. Now, this particular slide talks to you about environment. It tells you that different racks we have and how we run the test. This slide talks about the different levels of testing that we do on a hardware test, where we run hardware disk stress tests or memory stress tests, etc., which is linked to CPU. You have a fan test that we run, thermal level test we run, or if you want to do configuration check, then we have BIOS, BMC, LAN, all of these different tests that we run to make sure that there's uniformity across different servers in the total cluster solution. or if you want to make sure that, the system info check to make sure that the chassis that we're running, what kind of chassis it is, what product we're using, what is the motherboard serial number, all of those things, those information will be provided to you on the document when we run all of these tests. Moving on to the next slide. This basically talks about the FIO test or memory test, and also the document that we will provide to you, which will tell you, what is the MAC address, what is the serial number of the chassis or the server, to make sure, what tests have been run, etc. Again, the slide is just diving deep into showing you guys how our environment look, which is completely automated. So no matter whether it's running a cluster solution for one rack or hundreds of racks, we have the infrastructure to do that, and you don't have to worry about any of those things. So we could do the complete integration of this total solution based on what solution you pick and your requirement, or we can just do an a la carte where it is doing the total cluster solution, installation, testing, integration without the rack. Now, we have also run different tests where we have used Intel Optane drives for our big data solution. We have used BigTwin server as part of it. We have also used big data solution, BigTwin servers with Red Hat or VMware vSAN for running HCI solution and using Intel drives and Intel memory, Optane drives, etc. This particular slide talks to you about the use case where we have, one total rack level solutions where we're using not just one rack, but multiple racks. In this case, there are 4 racks that are being used, and these are petabytes of storage solutions, which competes again, or your tier 1 competitors like IBM, EMC, NetApp, any of those things. In short, Supermicro has the flexibility and all the ingredients to actually provide you the total solution where we combine with different software partners and Intel as a key vendor and use hundreds of different servers that Supermicro has to fulfill your requirement. That's it from me. Thank you so much. I now hand it over to Sim.
Learn more at supermicro.com, powered by Intel.